All right, here we're just looking at some more examples for simplifying rational expressions. I'm going to go through just a simple rational expression here to start, and then I'm going to look at multiplying rational expressions and dividing rational expressions. It's going to get more complicated as we go. If you need to fast forward the video to see those more complicated examples now, go for it. When we look at this, the first thing we want to do is always to factor the top and bottom. All right, I'm going to say that right here. Factor top and bottom. All right, factor everything to start. In this case here, the top, it has a GCF of 4, leaving me with x squared minus 2x minus 8. So I'm really looking at what multiplies here to get negative 8 and adds to get negative 2. If this is a struggle for you, go back and practice factoring. You need to be able to factor to do this. Well, in this case, the product is negative, so I know it's negative and positive. And I know the different signs means they're going to have a difference of 2 where our larger number is negative. That gives me 4 and 2 is my result. Giving me a top now of 4 times x minus 4 and x minus 2 because it was a just x squared problem, which is why they use the shortcut. On the bottom, there's no GCF, no x squared, so I can just put that x plus 2 in parentheses. Sorry, missed my plus up there. All right, now, once I've factored the top and bottom, I want to remove my giant ones. All right, giant ones is anything that is a number that is the same on top and bottom, a variable that's the same on top and bottom, or a group that is the same on top and bottom. Remember, numbers could even be like 8 over 4, all right, which that could reduce down to 2 over 1. All right, so keep that in mind. It doesn't have to be the exact same number when you're dealing with numbers. Here, numbers, I got 4 on top, but nothing on the bottom. Variables, I have no variables outside my parentheses, so groups. My groups, I have an x plus 2 and an x plus 2. Remember, they make a giant 1, so 1 is left over. That leaves me with 4 times x minus 4 on top, which is 4x minus 16 when multiplied back together, over top of 1. Now, do I need to write that over top of 1? No, I do not. So I'm just going to remove it here because I can just leave it as 4x minus 16. This will be the simplified expression as long as x is not a certain value that will make our denominator 0. So let's look back at our denominator. X plus 2 is the denominator. What value of x can't we use? Oh, sorry, let me state my thing. So multiply together what's left, and then 4, state the excluded values of x. All right, so in this case here, x cannot be negative 2 because if x is negative 2, then our original expression right here, the denominator would become 0, and that's not allowed. All right, let's look at the next one. Now, all of a sudden, we've got more here. All right, we're doing the same steps. Factor the top, factor the bottom. Then look to cancel out and remove your giant ones. Multiply what's left together and state the excluded values of x. In this case, we've got ourselves 4 factoring problems. So I'm just going to set myself up to where I'm going. In this first one, I noticed no GCF, so it's going to go down to 2 groups. And I notice it's a just x squared, so it's x and x. And I notice that just x squared means I just need the x in my diamond problem where my product is negative 1, but in this case, my sum is 0. What multiplies to get negative 1 but adds to get 0? Well, negative 1 and positive 1. That is a difference of squares as well for those of you that noticed it. Let's do this one here. I notice here I've got a GCF of 2. 2 goes into 12 and 14, leaving me with x squared minus 6x minus 7. Once again, I notice it's a just x squared, so my groups are going to go down to just x and x. And what multiplies then to get negative 7 but adds to get negative 6? Well, negative 7, positive 1. So plus 1. Yep. And minus 7. There we go. All right, on this side over here, this one here, I'm going to pull out a GCF of 2 because 2 goes into 14 and 2. Leave me x minus 7. That does not have an x squared and therefore can't go any further, leaving me with just 2 times x minus 7. This one here I notice has a GCF of x. Anytime you have an x cubed, just a heads up for that, there might be a GCF of an x. In this case here, pull out that x, leaving me with x squared plus x minus 2. Once again, it's a just x squared, so I know I'm going to go down to x and x. And I'm looking for something that multiplies here to get negative 2 and adds to get 1. That's 2 and negative 1. Now, once I've factored, I remove all my giant ones. X minus 1, x minus 1. X plus 1, x plus 1. 2, 2. X minus 7, x minus 7. All those leave me with 1s left over, not 0. So on top I have 1, but on bottom I've got 1 times x plus 2, and I got to distribute that, giving me x squared plus 2x. And that will be true as long as x is not anything that would make a denominator 0. So let's go back and look at a few things. I'm going to start by looking here at that denominator. What plus 1 is 0? Well, negative 1. So x can't be negative 1. What minus 7 is 0? 7. So x cannot be 7. It's always the opposite. Here, what value of x would make just x 0? Well, it seems tricky, but it's just 0. If you have x all by itself, then if x is 0, then you have 0. All right, here, what plus 2 is 0? Well, minus 2. And then here, what minus 1 is 0? Well, positive 1. Oops, it kind of looks like it's 7 there. Positive 1. So those are all the excluded values for x that I look for. Those were all my denominators. All right, now let's look at division. In dividing, this one gets a little more challenging because we need to keep the first fraction or rational expression. But then instead of division, we're going to do our keep, change, flip. If you remember how to divide fractions, we keep the first fraction, change division to multiplication, and flip the second fraction, which is called the reciprocal. All right, we do not divide fractions. Instead, we multiply by the reciprocal. Once you do that, from here, you do the exact same thing that we've always done. And that is factor the top, factor the bottom, all right, on everything. On the left here, this one's going to be a little bit of a challenge because there's no GCF. All right, and it's not a special case, so we have to use our diamond problem generic rectangle. Plug in x squared bottom left, constant top right, multiply those to get my product, and my sum is still the coefficient of x. Finding here that negative 6 and 1 make this work. And then I can pull out my GCF for my rows and columns, giving me x minus 3 times 2x plus 1 all over. Let's do the bottom here now. This one's also going to be a challenge. All right, in this case here, there's no GCF again, so I need to use my diamond problem and generic rectangle, giving me 3x squared bottom left, 3 top right, giving me a product of 9, and a sum of negative 10. All right, and when I look at that, I go, all right, that's negative 9 and negative 1, giving me negative 9x, negative 1x, and I pull out my GCF again in my rows and columns, giving me x minus 3, conveniently, and giving me 3x minus 1. Over here, I'm going to multiply, and these ones are a little bit simpler, okay, because my first ones is the difference of squares. All right, so in this case, the square root of 9x squared is 3x, the square root of 1 is 1, and a difference of squares gives me 2 different signs. The bottom one's a perfect square trinomial, which means I could write it as a group squared, but I'm going to separate them just because we're canceling today. Square root of 4x squared is 2x, square root of 1 is 1, so that's in both of them there, and it's a positive perfect square trinomial in this case because it was a positive 4x in the middle. All right, now, once I factored top and bottom, cancel giant ones. X minus 3, 2x plus 1, 2x plus 1, 3x minus 1, 3x minus 1, leaving me with 3x plus 1 over 2x plus 1. All right, don't cancel anything from there. The ones you cannot cancel, the x's you cannot cancel because there's no parentheses around those groups. And if there were, like it was up here, they were not the same group and you couldn't cancel them then. I do need to state my excluded values of x now to finish this off. And x cannot be anything that would make our denominator 0. And in this case, we have to look at some special spots. We're looking at our two denominators here as usual. All right? But there's a third spot we need to look, and that is right here. The reason was originally this was the original denominator. All right, and some people might ask, well, then why not just look at this denominator and this denominator? Well, I also have to look here because we are technically dividing in this case. You can't have a denominator 0 because you can't divide by 0. Well, that means in this case, if I'm dividing here, if the top is 0, then I'm again dividing by 0, and that's not allowed. You can never have x be any value that would cause you to divide by 0. So let's just break it down, look at each one at a time. I'm going to start right here. What value of x would make x minus 3 0? Well, 3. It's the opposite of minus 3. This one right here, though, 3x minus 1, that can be a little bit more challenging. I don't want 3x minus 1 to equal 0. So what value of x would make that happen? Well, the opposite of minus 1 is plus 1. And now this is 3 times x, so I can divide by 3 because the opposite of multiplying by 3 is to divide by 3. I see that when x is 1/3, 3x minus 1 will be 0, so x cannot be 1/3. That's the long way to figure this out, but there's an easier way. It's always the opposite of the constant, then divide by the coefficient of x. So in this case right here, 2x plus 1, the opposite of the constant plus 1 is negative 1. And then divide by the coefficient of x, which is 2. All right? So here, same thing. I already got that one, negative 1/2, so no need to do it again. Up here, the opposite of 3x minus 1. Well, I actually already did that one down here, if you remember, so we're all good there. So let's look at this last one here. The opposite of plus 1 is minus 1, and then divide by the coefficient of x. So negative 1/3 would make that 0. So this is our final result and all of our excluded values of x.